Hello and welcome back. Today we're going to be extending our knowledge of one-way ANOVA and go through a demonstration of how to handle both planned comparisons and post hoc comparisons. Now, before we get into fitting the Omnibus Anova, we have to get a better understanding of the data that we're working with. So based on the background information from the worksheet, researchers were interested in how various coaching styles might impact a player's performance on the basketball court, and had elite college basketball players from 3 different universities as participants. At the first university, the coach offered praise when a player made a basket. At the second university, the coach was asked to criticize the players. And at the third, the coaches were asked to not give any feedback at all. So that third group is sort of a control group in this study. The researchers also recorded the number of times each player missed a 3-point shot. So if you're not familiar with the rules of basketball, a 3-point shot is just a shot really far away from the basket. All right, so with this background information, let's go ahead and go through the first few steps of the research process. And the first thing, of course, is understanding our research question. In this case, we're asking if coaching feedback influences performance of basketball players. And here we have one independent variable. That is coaching feedback. So coaching feedback type. And the dependent variable will be performance, or number of baskets missed. We also know with our independent variable of feedback that players either received praise, criticism, or no feedback. So we have one independent variable that's categorical and has 3 levels. That information together tells us that a one-way ANOVA will be the most appropriate hypothesis test for this research question. Remember that a one-way ANOVA simply means we have one independent variable. In our next worksheet or our next practical, we'll start getting into factorial ANOVA. That simply means we have 2 or more independent variables in the research question. The null hypothesis for one-way ANOVA is simply that the mean number of missed baskets for praise will equal the mean number of missed baskets for criticize, will equal the mean number of missed baskets for no feedback. Essentially, there is no difference between the 3 groups. Now, the next really important question we have to ask ourselves is if we have any a priori hypotheses based on the information given in the worksheet. And as of right now, we don't have any a priori hypotheses about which group will perform best. This will really dictate whether our comparisons after the Omnibus Anova are going to be considered post hoc comparisons or planned comparisons. Functionally, the process of doing a planned comparison or a post hoc comparison is essentially the same thing. It will just dictate what type of decision rule we make or what type of adjustment we make in our comparison. All right, so we'll get into that a little bit more as we go throughout the practical. But as of right now, we don't have any a priori hypotheses or any underlying assumptions about which group will perform best. As researchers, we might already start to have ideas about which group will be best, but we don't have any a priori or planned comparisons. This means that our first step in answering this hypothesis is going to be considered the Omnibus Nova. That simply means the big ANOVA that includes all possible group comparisons. As our research questions and variables become more and more complex with more levels, we really want to be adjusting for a type 1 error. That's really what this process is doing. All right, so now before we actually get into the Omnibus Nova, let's assess some of our univariate statistics first. The first thing we have to do, of course, is import our data set. We're using the same link that we've been using all semester, and we want to import the coaching.dta data set. Okay, so now you can see we have the variable for feedback, which again is our categorical independent variable, and the number of misses. Now, if we look at our variable viewer, we just see feedback identified as 1, 2, and 3. Feedback of one refers to feedback of one refers to praise. Feedback 2 refers to criticism, and feedback 3 refers to no feedback, or that control condition. So that's definitely something to remember as we're going through this output. So again, first thing we're going to do is just look at our univariate statistics. Using the command tabstat, our dependent variable miss, and we want to get this information for our dependent variable of number of missed baskets for all levels of our independent variable. Okay, so the command tabstat miss by feedback will print out all of the statistics we're interested in for number of misses at each level of feedback type. Okay. So we have the number of observations, mean, standard deviation, skewness, and kurtosis for the praise group, for the criticized group, and for the control group. Right, and it looks like we have a balanced design. A balanced design simply means that we have the same number of participants or the same number of observations at each level of our independent variable. And then we have the mean number of missed baskets. Now, even though we haven't done any hypothesis testing at this stage, this is really why it's important to understand the difference between a priori hypotheses or planned comparisons and post hoc comparisons. A planned comparison, as the name suggests, is a comparison between two groups that you intend to do before you even collect any data. So to have an a priori hypothesis, you have to already have hypotheses about which groups will perform better before you even start collecting any data. And of course, this has to be grounded in existing theory. Let's say as researchers, you've collected some data and you just want to make sure that everything's looking good. So you look at some of your statistics, you look at the mean differences, even when you have more data to collect. At this stage, you might look at the means and think, wow, group 2 is really missing a lot more shots compared to the other two groups. So this group must be performing worse, right? If you didn't already anticipate that ahead of time before you started collecting data, you're already inflating that type 1 error here, or that false positive. So really the only difference between a planned comparison and a post hoc is going to be how strict the significance cutoff is. Okay, and again, that's really to adjust for the type 1 error rate. If you hypothesized before you even collected any data that group 1 would be significantly different from group 2, then you can have a slightly less conservative cutoff for that comparison. But in this case, we didn't have any hypotheses about which group will perform better or worse. So at this stage, even though we can see that the mean for group 2 seems to be higher compared to the others, we can't actually make assumptions about which group differences will be significant. So it's really important to do that Omnibus Nova first. But moving on, we can see that each group has some variability to it. And the skewness for groups 1 and 2 are slightly positive, but still within the acceptable range. Group 3 is a slight negative skew, but again, it's still in that acceptable range here. And with kurtosis, each group seems to be slightly platykurtic, but nothing too concerning here. Right now, ideally, we would also look at the frequency distributions, but for the sake of time, we're not going to do that today. Just know in your own work or your own assignments, you really should look at the frequency distributions as well. All right, so now that we've gone through our descriptive statistics, let's just jump into the Omnibus Anova.